Hello and welcome to this video where we're going to look at functions and equations. If you haven't already checked out these two videos on composite functions and inverse functions, I'd recommend you do so before watching this video. I'll put links to both of those in the video's description. Let's take a function f of x equals 2x plus 7 and we're going to solve three different equations using this function. So the first equation is f of x equals 17. Now since we know that f of x is 2x plus 7, we can leave the right hand side as 17, but on the left hand side replace the f of x with 2x plus 7, like this. We now just have an equation to solve. This one's quite straightforward. We subtract 7 from both sides. On the left, this leaves us with 2x, and on the right, 17 takes 7 is 10. And then we divide both sides by 2 to give you x equals 5. Now this second equation is a little bit different. It doesn't say f of x equals, it says f of 3x equals. So we'll still leave the right hand side alone, that's 31. And for the left hand side, we're going to start with f of x, so that's 2x plus 7, but we've been asked for f of 3x instead. This means the input here is 3x rather than x. So all we need to do is replace all of the x's in our function with 3x instead. So let's remove that x and change it for a 3x, like this. So the left hand side is now f of 3x rather than f of x. Let's just solve this equation. We need to multiply this bracket first, so 2 lots of 3x is 6x, and then plus 7 equals 31. We can now take 7 from both sides. On the left this gives you 6x, and on the right 31 takes 7 is 24. You can now divide both sides by 6, and this leaves you with x equals 4. It's a similar idea with this final equation. So the right hand side equals 27, and on the left hand side we'll start with f of x, which is 2x plus 7, but we're going to replace all of the x's with this new input here of x minus 4. So let's remove that x, and in its place we'll put an x minus 4. And now we can just solve the equation again. So if we multiply out the bracket first, we've got 2 lots of x, so that's 2x, and 2 lots of negative 4, that's negative 8. And then plus 7 equals 27. This negative 8 plus 7 here will simplify to give you negative 1. So we've got 2x minus 1 equals 27. And we can solve this by adding 1 to both sides. This is 2x equals 28. And then we divide both sides by 2, leaving us with x equals 14. Now in this question we've actually got two functions, one for f and one for g. Let's start off by solving g of x equals 0. So if g of x equals 0, we know what g of x is, it's x squared minus 25, so let's replace the g of x with x squared minus 25, and the right hand side is equal 0. You should recognize this as a quadratic equation to solve, and it's specifically the case of the difference of two squares. This means we can factorize it into two brackets, x plus 5 and x minus 5 equals 0. This will give you two solutions. So for the first bracket we've got x plus 5 equals 0, which gives you a solution of x equals negative 5. And the second bracket x minus 5 equals 0 gives you a solution of x equals 5. Now let's look at another equation. So this one's going to be a little more complicated. It's going to involve both functions. So we're going to solve g of x equals f of x. So we've been given both of those functions in the question, so we can just write g of x, which is x squared minus 25, equals f of x, which is 3x minus 15. So we just replace the functions in the equation with the functions we're given in the question. This is also a quadratic equation to solve. In order to solve this one, we're going to need to get all of the terms on the same side and the other side equal to 0. So I'm going to get all of the terms on the left hand side and make the right hand side equal 0. To do this, I'll need to subtract 3x from the right hand side, but also plus 15. This will mean the right hand side equals 0, but on the left hand side, if I subtract 3x and plus 15, I get x squared minus 3x, and then I need to do this negative 25 plus 15, which is negative 10. Now this quadratic isn't a difference of two squares, but it will factorize. If we look at the final term of negative 10, we're looking for two numbers that multiply to give this, but also add to give negative 3. This would be positive 2 and negative 5. So we end up with x plus 2, x minus 5 equals 0. This gives us two solutions again. So for the first bracket, x plus 2 equals 0, which means x must be negative 2. And for the second bracket, x minus 5 equals 0, which means x must be a positive 5. Now for one final question. This question involves the previous topics of composite functions and inverse functions, as well as functions and equations in the same question. So we're going to solve f g of x minus g inverse of x equals 0. So what we're going to do is focus on this composite function f g of x first. So we're just going to work out what that function is. To work out this function, we write the f function, which is x squared plus 9, but instead of an x, write a bracket. So instead of x squared plus 9, it's bracket squared plus 9. Then inside this bracket, we put the whole g function. So that's this x minus 3 over 2. Now if you have a bracket all squared like this with a fraction inside, you can just square the top of the fraction and square the bottom of the fraction. So if we square the top, it's x minus 3 all squared, and if we square the bottom, it's 2 squared. And then we've got this plus 9 at the end. Now x minus 3 squared on the top is actually the same bracket written twice. It's x minus 3 times x minus 3. And on the bottom we can do 2 squared, that's 2 times 2, which is 4. And then this plus 9 at the end. So what we need to do is expand out the brackets on the top. Let's start with x times x, which is x squared, x times negative 3, which is negative 3x, negative 3 times x, which is also negative 3x, and negative 3 times by itself, which is positive 9. These two terms in the middle will simplify, so negative 3x subtract another negative 3x gives you negative 6x. This is all over 4, and then we've still got this plus 9 at the end. So this is what we get for the composite function fg of x. Now let's look at the second part of this equation here, g inverse of x. So we need to work out the inverse function for g. So to do this, we're going to write the g function out, but write y instead of g of x. So y equals x minus 3 over 2. Then we swap the x's and y's around, so it's x equals y minus 3 over 2. And then we're going to rearrange this to make y the subject. To do this, we'll multiply both sides by 2. On the left hand side, that's 2x. And on the right hand side, that will cancel the 2, so it's just y minus 3. Then we can add 3 to both sides. On the left hand side, that's 2x plus 3. And on the right hand side, that'll cancel the negative 3, leaving you with y. We can now replace the y with g inverse of x. And since we usually write the function bit on the left hand side, we'll just switch the order around. So this is your inverse function, g inverse of x. It's 2x plus 3. We're now ready to form this equation. So the equation says the composite function fg of x, which is this function here, subtract the whole of the inverse function, which is 2x plus 3 equals 0. So we just need to solve this equation here. I'm going to start by looking at this bracket at the end here. Since we've subtracted the whole of the inverse function, this negative will affect both of those terms. You could imagine it's a negative 1 in front of the bracket. So if we do negative 1 times 2x, that's negative 2x, and negative 1 times positive 3 is negative 3. So we can remove this bracket by putting negative 2x subtract 3. Now I'm going to multiply through by 4 on both sides. If I multiply by 4 on the left hand side, every single term needs to be multiplied by 4. Now for the fraction, that will cancel the 4 that's on the bottom, just leaving me with x squared minus 6x plus 9. Then I need to multiply the 9 by 4, that's 36. Then the negative 2x by 4, that's negative 8x. And the negative 3 by 4, that's negative 12. And also the right hand side by 4, but 0 times 4 is still 0. Now that we've got it all on one line, we need to collect up our like terms. So we've got an x squared. Then if we look at the terms in x, we've got negative 6x subtract 8x, that's negative 14x. And then if we look at the constant terms, we've got plus 9 plus 36, that's 45. And then if you subtract 12 from that, you get 33. So plus 33 equals 0. Once again, we've been left with a quadratic to solve. This one also factorizes. If you look for numbers that multiply to make 33 that add to make negative 14, there aren't too many options to choose here. You actually want negative 11 and negative 3. And this equals 0. This gives you two solutions, so for the first bracket, x minus 11 equals 0, in which case x must be positive 11, and the second bracket, x minus 3 equals 0, in which case x must be positive 3.